Hello everyone. Since there is not much content on YouTube, today I wanted to show you how I connect to my SLURM cluster. Well, it's not actually mine, it's of my university, and how I use SLURM to manage my jobs. And I will show you a quick way to request some interactive GPUs if you have to run some computation intensive experiments. So I'm here from my host, and I will show you. If we go to the desktop and go to check the script, this, as you can see, uses it's the script that I use to connect to the cluster, and in this case I have I use SSH. I give the path to my key, to my SSH key. Then I put in my username and the cluster IP address. In this case, the cluster is, as I said, of my university, and it handles the credentials with the university default credentials of Google. So as you can see, when I will connect, it will ask me to prompt in the password. So let's just execute the script. I don't know why it doesn't find the key here, but whatever. I just connected here, so it probably works even without the SSH key. So once you're in, you have as you can see, I have a Linux bash opened. Here, as you can see, I have my home folder with all of my stuff. And one thing that you usually do is you want to check if there are any GPUs available. So let's suppose that now we are trying to, let's say we want to debug some code, or we want to try to run some parallel code. So let's say that I want to get a couple of GPUs. First of all, I want to see the status of the server. To do that, I first activate my virtual environment. In this case, I have, since I'm working with Dino, I created an environment which is called DinoEmp. It's just as a Python, PyTorch, and CUDA installed. I just activate it, and I use nodoc, which is a very cool program, which is this one. No, it's not this one. This one. So it's basically a terminal-based application that basically shows you the state of the cluster. So it shows you the jobs, the GPUs available, and the overall state of the cluster. So you can just download it and install it with pip. So I run it, and it takes a couple of seconds. Now, as you can see here, I have this very cool thing. So here I have all of the jobs that are running right now. The server is pretty full right now. As you can see, there are many people running their jobs. So here there is the job ID. Well, it's a little bit bugged here actually. Let me redraw maybe. Why? Okay. So this is the job ID, and then there is the job name. We have the user, we have the state, we have the time, and the RAM required in this case. I think this is the GPU, and this is the node, right? Here on the right, we have the nodes. So basically, a cluster is just some nodes connected together. Nodes are, you can imagine them as computers, and each node, each computer has some GPUs attached. In this case, for example, we have Franco, which has 4 GPUs. Patagarro has 4 GPUs, and so on and so forth. As you can see here, sometimes you might see, let's say, this little dash between two GPUs. It means that some user ask for those GPUs in parallel. I mean together. So the user is using those two GPUs at the same time. As you can see here, basically all of the GPUs are being used. It doesn't mean that there are no GPUs available. In fact, there are actually a couple of GPUs available, which are the empty squares here, or the empty symbols. In this case, right now we are in ILB login 03, so we are in the login node. So we are in this node right here. And all of these GPUs here are called debug GPUs. That's because they are basically let's say smaller GPUs, a little bit older, which we can use to debug code basically. So you shouldn't train on debug GPUs. Usually you should train on production GPUs. But if you need to run some test code, it's fine to request some debug GPUs. So let's try to ask two GPUs. I already have the command ready here. So history graph SLRUM. So the command should be this one. Okay, so this is the command. You have to know that in SLURM there are two main commands that you need to be familiar with, and those are srun and sbatch. Sbatch is used to basically to launch a job, so launch your program, your script, your training script, or your inference script, or whatever, and it is going to run in background, and SLURM is going to handle the priority of your job based on the amount of resources that you have, based on the priority of your user, and based on rules prompted in by the system administrator. In this case, we are using instead SRUN. SRUN is used when you need an interactive shell. In this case, since I want to debug some code, I want an interactive command line. So when you use SRUN, SLURM is going to look for the resources that you ask and is going to give them to you in an interactive way, in an interactive shell. So in this case, this is my command. So we are requesting for two GPUs. This is my account. In this case, I am using the computer vision account, the account of my computer vision course. Since this cluster is managed by one of my university professors, basically what happens is that every time you join a course in which you need to work on some project or some assignments, you are assigned to you can use the resources of the account for that particular course. In this case, I'm using the resources for the computer vision course. This is the partition. So I'm requesting for GPUs in the all serial partition, meaning that we're asking for debug GPUs. In our SLURM clusters, there are two GPUs, which are all serial and all user prod. Well, actually, there are also a couple of more partitions that were added recently, but those are the two bigger ones. And all serial is used for debug. And it's going to give us, it's going to give you the GPUs that I showed you before. Then we are requesting for 10 gigs of RAM, so not a lot of RAM. And we are requesting a shell, a job which is an interactive job, and it lasts for 1 hour. And then this -/-pty bash is because we want a bash. You can put in whatever other kind of bash you want, but I think bash is the only one supported in this cluster. Okay, so let's run the command. It's gonna take, okay, so as you can see, it already worked, but this might take a long time if the server is particularly full. So when you're using interactive, so when you want an interactive shell, it's usually a good idea to check the state of the cluster before requesting for resources. So now we have our interactive shell, as you can see. one thing that I did not do that I'm going to fix right now. So let's exit for 1 second. So if you exit, as you can see, you go back to the old node. In this case, we are going. So let me go back for a second. We are going to do this thing: node list equal to I login 03. That's because the basically when you're requesting for GPUs, you can be redirected to any node that has a GPU available. In this case, with the -- node list, you are specifying on which node you want to be redirected to. In this case, I want to be redirected to ilblogging 03. And that's because if you're redirected to ilblogging 02, right now it's not working because it has some problems with drivers, or I don't really know why, but it just doesn't work many times. If you import Torch, it just doesn't work. So we want to specify this node. So let's rerun the command. And as you can see now, I am on the node that I specified. So I blog in 03. So sometimes it's lagging a little bit, but as you can see here, we have a shell. So let's now, so if I just run Python and I want to import Torch, no, it works anyway because Torch is probably installed system-wide, but maybe if I import, let's say, pandas, it works anyway, whatever. So actually many packages, as you can see, are already installed in our cluster, but it's usually a good idea to activate your virtual environment with your own packages because you can manage the versions and stuff like that. So now let's run Python and import Torch. We can check the Torch version in this case. So you can see we have Torch 2.6 with CUDA 12.4 installed. One more thing that I want to show you, let me get out of Python 1 second, is if we run this Q command and specify our user, you can see that we have our job active. So as you can see, we have it's 1 minute and 22 seconds that I requested the resources, the node list, and everything. So if I run it again, as you can see, the time has changed. Another thing we can see is if we run nodoc and if you run nodoc, come on, and we look down here, as you can see, we have these two blue dots that were not there before. And that's because those are our two GPUs that we asked for. As you can see, there's the dash in between because we asked for two GPUs at the same time. Okay, so let's go back to Python. Let's import Torch. So let's now see if we have the two GPUs available in Torch, in Python, in our environment. So how to do that? We do torch dot, we print torch dot CUDA dot, I don't remember the command exactly, torch check devices. So this should work. So the command is, where is it? Yeah, first thing you can do is available. As you can see, it says true. It means that CUDA is working. And to check the name of the devices, what you do is, if it's not there, it's probably get device name, that's it. Get device name. So in this case, we have two devices. So the device is the technical term to that stands for GPU. So if we do print torch.cuda.is available, .cuda.get device name, and we prompt in the first device, which is the device with index 0. As you can see, this is the name of the GPU that I'm using right now. And if we ask for the second device, as you can see, it's the same GPU. It's not the same GPU, it's actually another GPU. It just has the same name because it's the same kind of physical product, but it's there are two different GPUs. If we ask for the third one, it obviously doesn't work because it says invalid device ID because we just have IDs 0 and 1. So for example, we could try to create a new tensor in one of our two GPUs. How to do that? We just use, for example, this, just to check if everything works. And in this case, if we do x.getDevice, it says that that specific tensor is right now stored in the first device. What we can do is we also do, for example, torch.cuda.get device name, and obviously this will return the name of the device on which the tensor is now stored. And this just to make sure that everything works fine. So now you have your interactive shell. You can run scripts in there, and you have your GPUs available. That's it for today. It was just a very quick video to show you how to get some interactive resources on a SLURM cluster. Thank you.